All right, so use frequency table to answer the questions below. Hey, this is kind of perfect. This is what we just talked about. So this would be seeing if you understood what we just did. So number 5, this is letter A. How many total data points are there in the table? Data. This is your data over here, because those are your different options. They could be colors, they could be numbers, they could be flavors of ice cream, but that is your data. So how many total means you need to add them together, data points are there in the table? Guys, eyes up here. Ima, up here, please. Boris, come on. How many different data points do we have? No, it is 4. It is 6, 7, 8, and 9, which is 4. Okay, that's your data. Letter B, how many times was the number 8 selected? Yes, 15. It's okay, you can say 18. Sound like you said 15. Amy, come on. I'm trying to help you here. I want you to do well. I want everybody to do well. Letter C, what is the maximum data value in the data set? What's the maximum value? Maximum means the highest, yes. No. What is the maximum data value? 9, yes. You're still talking about the data in general. Okay, so data is on the left. How often it came up is on the right. Calculate the probability. Finally, we get to probability. Numerator over denominator, that a 6 is selected. So we did an experiment. How often did 6 come up? 11 out of? Well, you tell me. 61. Yes, the total here is 61. You add all those numbers together and you get 61. The last one, calculate the probability that an odd value is selected. What's my total? What's my denominator going to be here? Down here. What's my total? 61, right? Now, I want the probability that I get an odd value. Of the values we have, which ones are odd? And 9. How many times did we get 7? How many times did we get 9? What do you think we should do with those? Add them together, yes. So 13 is how many times 7 came up. 22 is the number of times that 9 came up. Add them together, and you get 35 out of 61. What would be the probability of getting a 6? What would be the theoretical probability? Theoretical probability of getting a 6. Theoretical probability of getting a 6. I know that's not up there, but what would it be in theory? How many numbers do you have total? No. Theoretical probability of getting a 6 in theory. Yeah. And it's 4, and 6 is 1 out of those 4. Okay. Now they didn't tell us they had a die, a four-sided die, or a four-sided spinner, but that's kind of what I was trying to tie it into. Okay, that's what it is in theory. And then the experimental was 11 out of 61. That's the experimental. Okay. Any other questions on 5? Loris? Yes. E? Okay, yes. Calculate the probability of an odd value. So let me erase some of this. The odd values that we have over here, an odd value would be 7 and 9, correct? Because 7 and 9 are odd. We want the probability of selecting those odd values. Well, 7 came up 13 times out of the total of 61. 9 came out 22 times out of the total of 61. So to get an odd value, I would add the number of times that we got 7 plus the number of times that we got 9, which is 13, plus 22, which is a total of 35 between those two odd numbers, out of adding all of these numbers together, which is 61. Does that make sense? So if I said calculate the probability of an even value, then I would take 11 plus 15, add those together, and put that over 61. Okay? Good question. I'm so glad you asked. All right. Any other questions on 5? Let's go to number 3. Hey, we get to eat some candy here. How about that? That reminds me, I owe some people some candy, I think, from answering yesterday. We have a bag. Donathan, can you shut the door, please? That lovely, I know, he never shuts the door. A bag contains 6 cherry, 8 strawberry, and 9 grape-flavored candies. How many total candies are in the bag? Survey says... No. How many total candies are in the bag? 23. Total means you add. So 6 plus 8 plus 9 is 23. Total means you're adding, right? Alexis, you with me? Okay, good. You select one candy. You look at it, you're like, oh, I don't like that flavor. So you put it back in the bag. Then you select another candy. What is the probability of getting a grape candy first? And then selecting a cherry. Come on. All right, so I have a first draw and a second draw. Don't worry, it'll all be over after tomorrow's test. What? Yes, test is tomorrow. What is the total number we have on the first draw? The total number. 23, that is your denominator, right? You are trying to select a grape. How many grapes do you have to choose from? 9. And we assume you got a grape, but you don't like grape flavor, okay? So you put it back in the bag. So for my second draw, how many do I have to choose from total? I still have 23 because we put that candy back. But this time I want to get cherry. How many cherries do I have? 6, yes. And what do I do with these probabilities? Do I add them? Do I subtract, multiply, divide? What would I do there? No. If they have nothing to do with the other one, they are called independent. Anytime you have independent events, You multiply. You almost always multiply. So 9 times 6 is 54. And I need someone to calculate 23 times 23. A little louder. I still didn't hear. Thank you. 529. That is the probability of getting a grape candy first and a cherry second. Now, let's go to the last one. You select a candy. This is new problem, but we still have 23. You select a candy, you eat the candy, crunch. And then you select another candy. Calculate the probability of getting a strawberry each time. So again, we have 2 draws. Put these lines. I think they help a lot. First draw, second draw. So how many do we have total again for the first draw? 23. How many of those are strawberry? 8, yes. So when you take that first draw, we assume you get it. Here's a strawberry. Crunch. Isn't that tasty? You don't have it anymore. So how many are in the bag now for the second draw? 22, because you ate one of those pieces of candy. That piece of candy just happened to be strawberry. So how many strawberry candies do you have left for the second draw? 7. Yes, you have 1 less. 1 less. So multiply those 2 together. 7 times 8 is 56. All over 23 times 22, which is 506, I believe. Is that correct? And there it is. Questions on that? So again, I really am a proponent and an advocate for put the blanks down when you are trying to say, how many total do I have? How many of this color? Okay, I put it back in. How many total here? How many here? All right. So let's go to our last 2. Do we have time? Ooh. Don't know that I have time to do both of these. I'm going to go very quickly on number 2. Okay? So, what is the probability that an 8th grader is selected at random? That is not conditional. If it's not conditional with a vertical number, the denominator is always the total. So that's over 900. The probability that it's an 8th grader, you want all 8th graders. So that is 250 over 900, and we are not reducing our fractions. Calculating swirl or 8th grade. That means I want all of the swirl plus all of the 8th grade minus swirled 8th graders minus what is common to both. So swirl, all of them, 533, plus all the 8th graders, 250, minus, look where they intersect, and try to read that number. What is that, 168? Right here. That's what's common, 168. This is all over 900. It is not conditional. So 533 plus 250 is 783 minus 168 gives me, whoops, that's a 1, 615 out of 900. Think of this as a U and united. If you are united or a union, you want everybody to participate, as many as you can, except for those that get counted twice. Letter C is conditional. 6th grade, given that they like swirled ice cream, that swirl is your new denominator. Swirl on the bottom, 533. The 6th graders that enjoy swirl ice cream go back, and that is 212. What's the probability an 8th grader selected at random prefers strawberry? There's conditional. All 8th graders are now in the denominator because that's conditional. 8th grade, let me erase this. All 8th grade is 250. Of those 250 8th graders, how many like strawberry? 82. Okay. And the last one, what's the probability that someone selected at random from this is a 7th grader and likes swirled ice cream? You need to look at where they are intersected. So 7th grade, whoops, wrong one. 7th grade and swirled, they both go through 153. Very, very quickly. Number 1, bias. Bias is bad, okay? It's either bad because someone is trying to make you think the way they are by saying, oh, this is fantastic, or that's horrible, okay? They're trying to get you to come their way. So select those that are biased. If somebody asks you, how many hours do you sleep each night? Is that bias? No. That's not bias. Letter B, don't you think Pike's new cell phone policy is a great idea? Is that biased? Yeah, they're saying it's a great idea. We don't know if it's great, but they're calling it great. That's bias. Letter C, would you like a delicious candy bar or a vegetable for a snack? Does that show bias? Yeah, they're biased towards the candy. And what about, what bus do you ride each day? Is that biased? No. So those are the answers. We have gone through all the problems at this point. If you are with me on this remote learning,